This is David Fenella, Senior Director of Engineering at the Concrete Reinforcing Steel Institute, and it is my pleasure to introduce our latest publication titled Seismic Design Guide for Steel Reinforced Concrete Buildings. This design guide is based on the provisions of the 2019 edition of ACI 318 and covers cast-in-place concrete buildings with non-pre-stressed reinforcement located in all seismic design categories. Design and detailing requirements are organized with respect to seismic force resisting system, and design aids, design procedures, and examples are provided that illustrate the proper application of the code requirements with an emphasis on constructability. The table of contents of the publication is shown here. I would like to highlight some of the key information in each chapter. Chapter 2 contains a summary of the seismic design criteria in Chapter 11 of the 2022 edition of ASCE 7. Shown here is an example of the new multi-period design response spectrum that is used in determining seismic forces. The seismic design requirements in Chapter 12 of ASCE 7 are given in Chapter 3. The information in this chapter is used in all subsequent chapters of the design guide. Step-by-step procedures are given on how to calculate required seismic forces. A summary of the permitted properties for concrete and steel reinforcing bars based on seismic design category is given in Chapter 4. Also included in this chapter are the strength reduction factors in ACI Chapter 21. Design and detailing requirements for bearing wall and building frame systems are given in Chapter 5. The two-story building illustrated here is an example 5.2 in the design guide and covers the design and detailing of a bearing wall system with piers in seismic design category D. Example 5.5 illustrates the design and detailing of a 20-story building in seismic design category D, utilizing a ductile coupled wall system, which is a new seismic force resisting system introduced in the 2019 edition of ACI 318. It consists of special structural walls and coupling beams that satisfy the criteria in ACI section 18.10.9. The structure in this example is analyzed using a modal response spectrum analysis. Many significant revisions were incorporated into the 2019 edition of ACI 318 for special structural walls, including the determination of the design shear strength, which is illustrated here. Numerous detailing requirements were also revised for boundary elements in special structural walls. Ordinary, intermediate, and special moment resisting frames are covered in Chapter 6. Included are design aids that assist in determining the preliminary size of a joint in a special moment frame. Chapter 7 contains the requirements for dual systems. Information is provided for the systems commonly used in buildings assigned to seismic design category C and D. Shown here is the building in example 7.2, which utilizes a dual system with reinforced concrete, ductile coupled walls, and special moment frames in the north-south direction. In the east-west direction, there are special structural walls in combination with the special moment frames. Shear wall frame interactive systems, which are permitted to be used in buildings assigned to Seismic Design Category B, are covered in Chapter 8. Design and detailing requirements for diaphragms are given in Chapter 9. Comprehensive examples provide methods to determine all the required reinforcement. Example 9.3 illustrates the design procedure for a building frame system with a horizontal irregularity. Structural walls are terminated at the top of the first story, and the forces are transferred through the diaphragm to the edges of the building where there are the continuation of the structural walls. This example provides complete design and detailing of the semi-rigid diaphragm. Requirements for members not designated as part of the seismic force resisting system are given in Chapter 10, including an example of a building frame system with a flat plate floor system where shear stud reinforcement is required. Chapter 11 covers the design and detailing of shallow and deep foundations. Included is an example of a special moment frame supported by drilled piers with pile caps. Design checklists, which summarize the pertinent requirements covered in the chapters of the design guide, are also available as a supplement to the design guide. Spreadsheets are provided for the design checklists. For more information on this design guide, the design checklists, and other resources available from CRSI, please visit our website at www.crsi.org. Be sure to create a free account to receive information on our new publications and webinars. Thank you for your interest in CRSI resources.